Let's talk about synovial joints. So synovial joints are the most complex joints when there are several structures between two bones. All of the synovial joints are in our limb joints or neck, elbow, knee joint, thigh, shoulder, finger, jaws, toes joints, and all of them are diarthrotic. It means freely movable. So what is there between two bones in the synovial joint? You need to know that structure for your tests. First of all, ends of the bones are covered with a layer of articular cartilage. It's a thin layer of hyaline cartilage. So hyaline, it's a structure, what type of tissue it is made of. Articular, it's a name of it when it is sitting inside of the synovial joint. Next one, between of those two bones, there will be a space called synovial or joint cavity. Okay, joint capsule or articular capsule. It's a structure made of two layers covering that joint cavity from the outside. There is outer or fibrous capsule. It's also called articular capsule, made of dense regular connective tissue. And inside there will be synovial membrane. To understand better what synovial membrane is, imagine a balloon filled with water, and we take that balloon and we place it between two bones, and that is your synovial membrane, thin membrane, filled with synovial fluid. Synovial fluid is a slippery filtrate made of blood plasma and hyaluronic acid. It is for lubrication and nourishing that articular cartilage and to prevent friction when we move in our bones. What else can be found? Not shown in that picture, but on the outside there will be ligaments connecting two bones and reinforcing the whole structure, making it stronger. And also there will be lots of blood vessels going to those synovial membrane and ligaments, joint ligaments, to provide them with nutrition and blood supply and nerve supply. Some of the synovial joints are much more complex, and they are made not only of two bones, but additional bones, a lot of muscles, so many structures. Example is that is a knee joint. And in joints like that, you can find bursa. Bursa is plural, single will be bursa, ending with A. Those are also flat and fibrous sacs lined with synovial membranes. What does it mean? Again, we take a balloon filled with water, or actually synovial fluid, but right now we're placing it between the bone and between a muscle and or tendon. Here it is. To prevent friction between the bone and muscle and its tendon when we are flexing or extending our knee joint. There is one more structure, also balloon filled with water. That will be a synovial membrane with synovial fluid, but now it will be wrapped around a tendon. So tendons connect muscles and bones. Right here would be a muscle. That is a tendon connecting it right here to the bone. And to prevent friction, to prevent destruction of the tendon against the bone during movement, that tendon is wrapped into the tendon sheath. So you need to know the difference between synovial membrane, bursa, and tendon sheath. One more classification of synovial joints by the shape of the articular surfaces. Ends of the bones can be flat. That can be plain joint. Or it can be like ball and socket structure. Or sometimes it's saddle joint, looking like a saddle. You do not need to memorize all those types for your exam, but you need to know that those types exist. Now, classification of the synovial joints by the range of motion. What does it mean? How many movements you can produce in the one joint. Let's think about elbow joint. What can you do with the elbow joint? You can flex your arm and you can extend it back. That's it. That is called uniaxial joint. When you can make two movements, for example, you can move your index finger away from other fingers and back, and you can also move that finger back and forth. That's your biaxial joint movement in two planes. Finally, our shoulder and hip joints are multi-axial. It means we have several types of movements available in them. Here is a list of movements at synovial joints: flexion, extension, abduction, adduction, circumduction, rotation, supination, pronation, dorsiflexion, plantar flexion, inversion, eversion, protraction, retraction, elevation, depression, and opposition. It looks like a lot, but when you go through them, you will understand that you already know a lot of them, and it's not difficult to memorize. First, flexion and extension. If you look at your arm, it's made of two parts. Right here bone would be humerus, and here ulna and radius. And when you just stand in anatomical position, the angle between those bones will be 180 degrees. So whenever we start flexing our elbow, that angle will become smaller and smaller, 150, 130, finally 90, and even smaller than that. That movement is called flexion. When we are moving bones in the opposite direction and extending, making that angle larger again, that will be extension. Hyperextension. Sometimes we can move our body parts or bones over 180. For example, that is 180 degree right here angle between the torso and legs. And we can bend our torso back to increase that angle. That is extension. We can do the same with our head. Move it back from the body. Finally, hyperflexion, excessive flexion at a joint. Let's say most people can move two bones to the angle of 60, 50, and some people can do it to 30. It means that their joints are very flexible, and sometimes it can be a sign of a disease. Sometimes it's a genetic condition. Abduction and adduction. What is that? That is your midline of the body, mid-sagittal line, and moving your arm, leg, or any body part, even one finger, away from the midline is called abduction. So that would be abduction. Like we are abducting something away from the body, abducting that leg to the side. Adduction, it's moving body part or bone back to the midline, adding it back. Adduction, adding it back. Circumduction. It's a movement of a body region in a circular manner, in which one end of the body region being moved stays relatively stationary, while the other end describes a circle. What does it mean? Let's say you start making circle with your palm. It means this one, distal end of your arm is making circles, but this end of your arm is still attached at the shoulder point. That is circumduction. Rotation is something completely different. That's turning of a bone around its own long axis. Let's say we're turning our head left and right, and that's turning around the axis of the bone. Supination and pronation. That's about hand. Let's imagine you are standing with your palms up. That is supine position. Your palms are facing up. Now, right, like that. Now you're turning your palms up. That will be pronation. Turning hand forward. Now you're turning hand backward again. That is supination. How to memorize that? In supination position, imagine that you are holding in your palm a soup of bowl. of a bowl of soup. Sorry for that. That is supine position, supination. Okay, dorsiflexion and plantar flexion. That's upward and downward movement of our foot. Dorsiflexion and plantar flexion. Inversion and eversion is similar. It's again about the foot, moving it to the midline, medially, the sole. It's inversion. Moving it away is eversion. Finally, protraction and retraction. What is that? When we can move our body part, in this case it would be our chin, mandible. When we can move it ahead, it will be protraction. When we move it back, it would be retraction. Depression and elevation. Lifting of the body part will be elevation. Moving it down would be depression. We can do it with our chin, and we also can do it with our shoulders. We can move them up and down. Elevation and depression. Opposition and reposition is only about the thumb. Movement of the thumb. So the thumb touches the tips of other fingers like that, like thumb and index finger. That is called opposition when they touch. Returning the thumb in the original position back when it's not touching other fingers is called reposition of the thumb.